In this video, we'll cover percent composition of a compound. When we look at a compound, say C6H12O6, we describe this composition, how much of carbon, how much of hydrogen, and how much oxygen is in there by looking at the subscript that's below, the 6, 12, and the other 6. It shows that there is 6 carbons, 12 hydrogens, and 6 oxygen. We can look at the individual numbers that's next to it to say that that's how much of carbon, hydrogen, and oxygen are present within the entire compound. However, we can also describe this composition not just by how many of each atoms are present, but also by percentages in mass. In order to do that, you will need to know the following equation. It says mass percent is equal to the mass of element in 1 mole of the compound divided by the mass of 1 mole of the entire compound times 100%. Let's do an example that applies this particular equation. Here it shows C10, H14, and oxygen. And it asks how many atoms of C, H, and O are present. So we know that C, there is 10 of them. H, there's 14 of them. And oxygen, there is just 1 of them. Then the next question asks, compute the mass percent of each element in the compound C10, H14, and oxygen. Recall this right here on the top, that the mass percentage of each element is the mass of the element divided by the mass of the entire compound. So let's go ahead and find the molar mass of each of the element, also of the entire compound. So we're going to go ahead and look at carbon first. And carbon, underneath the periodic table, you'll see that carbon 12 weighs 12.01 grams per mole. If you were to equate this out and calculate this out, then you should get 10 times 12.01 is 201 grams per mole. And that's just for carbon. What about hydrogen? There's 14 of them, and molar mass for hydrogen is 1.01, and if you multiply 14 times 1.01, you should get 14 grams per mole. For oxygen, there's just 1 of them, so it is 16.00 is their molar mass, and so hence 16. That's for individual elements, meaning this is just for carbon, this is just for hydrogen, and this is just for oxygen. If you were to calculate the entire molar mass, you would add this up, okay? You would add this entire molar mass out, and you should get 150.24 grams of C10, H14, and oxygen. So let's go ahead, and we haven't even found the mass percentage yet, but let's do that now. The equation shows that the mass percentage is equal to, so I'll put it as M, is equal to the mass of the element divided by the entire compound, the mass of the compound, times 100%. So I'm just simplifying here a bit from what I had written above. So go ahead and do that for carbon. Carbon is 120.1 grams per mole divided by the entire compound is 200 and big mole there, 24 grams per mole. So grams per mole cancels out, and that needs to be multiplied by 100%. So let's go ahead and do that in our calculator. So let's take this calculator, and you're going to go ahead and open up a parentheses, press 120, 120.1, okay? And then divide it by 150.24. Close the parentheses. And then you're going to multiply by 100. Don't press any percentage sign. If you have a percentage sign in your calculator, just multiply by 100 and hit enter. Get this value here. That's approximately 79 with 4 sig figs, 79.94%. So that was for carbon. Let's try for hydrogen and oxygen as well. So this was for of carbon. So let's try for carbon and oxygen, or hydrogen and oxygen. So hydrogen was, for mass percent for hydrogen was 14.14 all over 150.24 times that by 100, and I should get 9 point, sorry, I already pre-calculated this one, 9.412% of hydrogen. So you can pause this video and see if you can do this on your own and try it for mass percentage for oxygen and come back. Okay, so coming back, so that's for oxygen. So what do you notice? You notice that the percentage of carbon is the greatest, then oxygen, even though there's only one of oxygen by mass, it shows that by mass they're more in content. And then hydrogen, okay? So this mass percentage is a little different from just counting up carbons, counting up hydrogens and oxygen, but it really shows which mass is greater in terms of percentages within that compound. We're going to do a learning check based on this, so go ahead and try this learning check right here. Here it says compute the mass percent of each element in the compound calcium hydroxide. I'm going to set you up a little bit and then you're going to try this on your own. So here we're going to first find out how many elements of each compound contain. So calcium, there's just one of them. For oxygen, there's 2 oxygens. Why? If you look over here, this indicates that there's 2 of the hydroxide. That means there's OH and another OH. So hence why there's 2 oxygen. And for hydrogen, there's 2 hydrogens. Now go ahead and find the molar mass of each of the element, which is right under the periodic table, and see what you get for each of the element. And then come back and check for that value and also the mass percentage. So coming back, this is the key. Something to note in the end is if you look at all the percentages here, if you add them all up, it should approximately equal to 100. It could be 99.89, 100 and maybe 0.5, something like that. But it will be approximately or exactly 100. So you could always double check your answers if 100% comes out in the end. And if it doesn't, then chances are there might have been a calculation mistake. So we're going to do the next one here. Go ahead and try the next one to compute the mass percent for each element in the compound C3H4O2, and then come back and check the key. And here is the key.